请那个 Michael Pan 为我们介绍说 Cloud Computing 在建制的过程中，你可能可以选择什么样的 Open Source 软体，以及说可能你会有什么样，欢迎大家在过程中提一些相关的问题，这样子。好，那我们就掌声鼓励，欢迎 Michael Pan。
Hello. Hi everybody. 所以我先讲一点中文。我今天讲题目是会在用英文来讲，但是等一下有问题的话，欢迎问中文，那我可以尽量回答。So today the topic we're going to talk about is open source software for building a private cloud. My name is Michael Pan. I'm the CEO and founder of Nephosity, an introduction about me and my company. I have over 10 years experience working on high performance computing, which includes distributed, grid, and cloud at various companies. Earlier this year in March, I started Nephosity, which is the company. Nephosity develops cloud computing platform for enterprises. And back in June at Structure 2010, which is probably the largest cloud computing conference, annual conference, we were showcased as one of the 10 most promising startups of 2010. Okay, so the question is, what is behind the cloud, right? So we all use a lot of cloud, different cloud applications like Twitter, Gmail, Flickr, Facebook, but we don't know exactly what's happening behind the scenes. And the reason we want to know what's behind the scenes is if you are one of those if you're trying to develop a SaaS application and you require elastic compute resources, and you want to deploy in the cloud, but you can't use a public cloud like Amazon because of security or performance requirements. So you want to use open source components in your cloud. So the question is, what's available to you? So why not use Amazon? Well, EC2, Amazon's EC2, which is more specifically dynamic provisioning, that's the capability provided by EC2, is only one part of the equation, right? The core is dynamic provisioning, but it doesn't do other things, which we'll talk about later. And also EC2, it's not open source. It's just a service that's provided. Even if you were to use EC2, you need a machine image to run on. So what's the software that you're going to install on this image? And then we're going to also look at what are other alternatives for EC2, open source ones. And if, in case you don't know what dynamic provisioning is, that's the definition there. Just, you can request compute nodes on demand. So what about Hadoop? I added the slide because in Taiwan, when you talk about cloud computing, everyone talks about Hadoop. But again, Hadoop is really only part of the equation, right? Hadoop core provides for MapReduce, and then HDFS provides for data management, right? But then there are other parts that are missing, such as how do you control your Hadoop jobs? And the other question is, what alternatives are there to Hadoop? Because as in our Bird of Feathers last night, I think we all agreed, the attendees there all agreed that Hadoop is not the highest performance, it doesn't have the highest performance functionality. Okay, so looking at the cloud computing stack, I sort of broke it out into three major sections. In each of those major sections, you have to make considerations about components within them. In infrastructure, we have hypervisor, dynamic, so we'll get into this later, actually. So the three major ones are infrastructure, platform, and cluster management. So before we go even further, a disclaimer. I'm really only going to mention about open source offerings that have been released, with one exception, and I'll mention that later. I'll present what's available, but not necessarily how to adopt or implement them, because that will actually take days, even months to talk about. The lists may be incomplete because there's so much open source out there, and hopefully, this will just get you started if you're looking for such things. And last, there's going to be some hand-drawn graphics. I'm not very good at using, PowerPoint, so you'll see some hand-drawn ones I scanned in. Okay, so looking at infrastructure, the infrastructure is really composed of three main things. You have a hypervisor and virtual machine. You have dynamic provisioning functionality, and you have the operating system. So if you look at the image here, at the very bottom, I wrote the M, so that's the actual hardware that you have, right? And on top of that hardware, you're going to have a hypervisor. That's the HV, right? And then that's sitting on top of the hypervisor, you have the dynamic provisioner, which is going to use the hypervisor to provide you with virtual machines. That's the VM. Okay, and on top of those virtual machines, you have the operating system. Okay, so Amazon's EC2 is really only the dynamic provisioner, right? It doesn't do any of the other stuff. And so today we're going to look at this whole thing here. Okay, so hypervisor virtual machine. What is it? Well, the hypervisor provides for hardware virtualization, and it allows you to run multiple virtual machines on a single physical machine. So these are some of the open source offerings available. QEMU, or QEMU, however you want to pronounce it, is the virtualizer itself. Then you have two hypervisors, KVM and Zen. And what they do is they take QEMU and then provide a virtualization functionality. You also have VirtualBox, except that's really only for the desktop usage. It's not it can be adopted for server usage, which is what we're really talking about when we talk about cloud computing. But currently, you can really only use VirtualBox on the desktop. Okay, so then dynamic provisioning. It allows you to allocate and deallocate compute resources on demand. You get the compute resources when you want, and the provisioner reclaims it when you release them, and you say you don't want them anymore. Available open source software include Eucalyptus, OpenNebula, Hazia, and Condor. And so those are the three that are released. And I'm mentioning Elaster because of T-Cloud, CC Lien here. He's been so helpful with the conference, so I thought I should mention it. They're about to come out with it, right, CC? Okay, so next, operating system. So the operating system is actually the interface between your software and the underlying hardware, right? And so in cloud computing, these operating systems are stored as machine images. They're just single big files that are loaded or distributed to the local the physical machine on demand, and then used by the hypervisor to boot into memory. You can think of it, with Ubuntu, the live disk, same thing, right? Except that it's not a CD, it's actually just a single file. Obviously, with operating systems, you have various Linux distributions: Ubuntu, SUSE, Fedora, CentOS. Generally, I think people generally use like Ubuntu and maybe Fedoras and CentOS. Ubuntu is really easy to use mainly because they've created an entire cloud distribution software around them. You can also use BSD, but that's really only on VirtualBox, which is for desktop. Okay, so we've talked about the infrastructure. So now we're going to talk a little bit about the platform. In the platform, there's four main things. There's data management, there's Mapreduce, workflow management, and messaging. And so if you look at the picture here, well, I've tried to show like how they stack up on each other, right? So at the very bottom, you have so the left and right are your nodes, right? And at the bottom, you have the virtual machine or the operating system. And sitting on top of that, you have the database management capabilities. And on top of that, you have the Mapreduce capabilities, because the Mapreduce takes the data and computes it. Then you have the workflow management on top of that, which allows you to control your Mapreduce jobs, but also your non-Mapreduce jobs. And then on top of that, you have your application, right, that uses the workflow management, uses Mapreduce to do whatever you need. And then you look at the center of the image, the way that the nodes communicate with each other, right? It's also it's a network stack, right? So at the very bottom, you have the Ethernet, which is the actual physical hardware. Then you have TCP/IP, which is the transport protocols. And then on top of that, what you really want is a messaging protocol, right? TCP/IP really only allows you to send data over a socket, but if you were to use TCP directly, you still have to do a lot of parsing of the data to figure out where your message begins and where it ends. So messaging should really help you really take care of that for you. So all you really have to worry about in your application is sending a message, discrete messages. Okay, so data management. So we'll go into each of these in a little more detail. Data management allows you to distribute your data across your network. And not only does it allow you to send that data, but you can also replicate that data across the network. It should help you optimize retrieval to improve your computation time, and it should also optimize your storage requirements. So it really depends. What ultimately comes down to is what are your data requirement needs, right? And so these are some of the considerations as you look at what open source software or any software that you need to implement, that you want to deploy, right? Is it structured? Is it non-structured, right? Because in that case, you can look at use SQL or NoSQL. What is the replication degree you want? So how many copies of each data do you want to have on your cloud? Are your files large or small, right? The replication strategy is different depending on whether or not you have small or big files. Do you want consistency or not? Consistency is if you make a change here on one node, do the other nodes see it immediately, or do they see it after a certain amount of time, right? And then there's centralized and decentralized, which is, do you have a master node that's controlling the data management, or is it all, distributed? And then you have to also factor in your access patterns. Do you query more than you store, or do you store more than you query? And also, what is the frequency of, reading and writing? So, data management is actually probably one of the hottest areas in cloud computing right now. There's a lot of software out there trying to help you manage your data in different ways, all dependent on, how you actually access your data. These are just some of the packages that are available. So, for example, Hadoop has HDFS, right? UIC, that's the University of Illinois, Chicago. They have something called SphereFS. Nokia has something called DiscoFS. DDFS, Disco something FS. And then, Facebook released Cassandra, which is now part of Apache. There's MongoDB, and there's CouchDB, which is also part of Apache. Oracle has MySQL because they bought out MySQL. PostgreSQL is, I think, an independent company. And then DreamHost released Ceph, which is actually just integrated into Linux itself. So, each one of them provides various different functionalities. We won't get much into it because I don't have that much time. But feel free to ask questions about it later. Okay, so the next thing, once you've decided on a data management strategy, you have to look at what your Mapreduce strategy is, right? So I think most people here know what Mapreduce is, but we'll go in and just overview it a little bit. So it allows you to split and parallelize a task into many parts, right? And once you've computed the individual parts, it allows you to combine the results back for a final result. So this image up here is supposed to show at the very left is your input, and that's, it's a large file which then has 5 parts that you split using a map. And then, there's a center thing, which is your shuffle sort, or whatever it is, your algorithm that computes the small one, and then finally a reduce that combines those results together into your output. So open source offerings. These are really the 3 main ones. I think everyone here knows Hadoop. UIC produces Sphere, which complements their file system that I mentioned earlier. Nokia produces Disco, which complements their file system that I mentioned earlier. Okay, so now we have workflow management. Workflow management is the design, specification, and coordinate execution of your compute tasks. So you can imagine that, with Mapreduce, all it does, it says you have one job to compute and it splits it up and recombines it. But then what happens if you have to do stuff before that Mapreduce job, or what you have to do stuff after that Mapreduce job, right? In which case, what you want to use is something like a workflow management. And here, it's a quick draw of a diagram. For example, you have job 1 up there, and after it executes, you execute the other 2. But then, it has to hold, after that, the right one finishes, you have to execute another one before you can actually finish the jobs. And then, of course, each one of these themselves can be Mapreduce jobs. So some open source offerings. Yahoo has something called Oozie. They just released Oozie end of June, so that's about a month and a half ago. Apache, along with Hadoop, also releases something called Pig, but that's really more of a structured query language. And then Concurrent releases something called Cascading that also sits on top of Hadoop. By the way, yeah, Oozie is also allows you to manage your Hadoop jobs. LinkedIn has something called Azkaban, And they also, they also use Hadoop. So Azkaban also sits on top of Hadoop. And then you have PalmSets. So I'm going to plug this one here because this is my company's. So PalmSets does Hadoop, but it also does non-Hadoop jobs, including Python, shell scripts, and just anything that you can run on the command line, PalmSets will be able to do. We also do a GUI. We also have a GUI, which the other 4 don't have. And PalmSets is open source, so please go check it out. Okay, so the other thing that you need in your platform is a way for all your different nodes to really communicate with each other easily, and that's a unified framework for messaging. As I mentioned earlier, it sits on top of the network and the hardware and network protocol layers, and that way it allows you to, for your application to not have to worry about parsing of raw binary data and just take messages themselves, handle discrete messages. So some of the offerings out there include Cupid, which is released by Apache, Rabbitmq. So Rabbitmq is actually owned by Rabbit Technologies, which is owned by SpringSource, which is owned ultimately by VMware. It was very hard to figure that one out, but it's a very big company behind them. So these things are all pretty stable. And then ZeroMQ is developed by iMatix. Within Nephosity ourselves, we actually use ZeroMQ. You can download the source, compile it, and be up and running in less than 5 minutes. So for us, it was really easy to use. Okay, so cluster management. Cluster management sort of sits outside of infrastructure and platform in that it's really, and also outside of SaaS, the software as a service, because people really don't think about it until they really need to scale their cloud. And what cluster management really does, it allows you to monitor the health of your cloud. And so it sort of sits outside your cloud, it looks at it, and it sort of does things as you need when you need it. So what are some, so cluster management generally includes stuff like configuration management, and then there's also visualization and reporting, which we also call analytics. So first we'll talk about configuration management. So configuration management allows you to configure your running cloud instances. Earlier we talked about machine images. So if you want to save off a particular configuration, you can actually create machine images to do so. But if you want to dynamically change your running instances, you need something like configuration management that can automatically go across all your cloud instances and make those changes. And the reason you would want configuration management instead of machine images would be something like software upgrades, right? You want to have zero downtime. So while you're running your cloud, you want to go through and you want to upgrade the machines as they are running. The other thing is there may be dynamic configurations that cannot be stored on OS images. For example, a lot of servers, of database systems required, at least the centralized ones, they need to know who their master is, and a lot of times you won't know what that master is until you have the master running. So you can't actually save off the master information until you've actually started up the master. So you need something like configuration management. And then also, there's storage constraints, right? A OS image actually takes hundreds of megabytes, if not gigabytes, and you may not always want to be saving off, gigabytes of data just because you want a small change to happen. In that case, use something like configuration management. Open source offerings for configuration management include Chef, which is owned by Opscode, Puppet, which is owned by HPLabs, and MIT. I was just at MIT last week, and they've also created a really easy-to-use one called Star Cluster. I think Puppet is actually Puppet and Chef, at least, they're both startups. And for example, Puppet is actually doing really well. They just got $5 million funding the other day. Okay, so analytics. The left picture didn't come out too well. So analytics allows you to capture information about the health of your cloud, and then visualization allows you to visualize that. And then once you have that information, it allows you, there's software that allows you to adjust the size of your cloud or the configuration of your cloud based upon that information. So, the data you can collect, for example, it's just, you could be compute load or network storage, but it could be, network usage or compute load. It could also be memory usage. It could also be, database usage, a lot of different things. And then dynamic load balancing allows you to start up new instances and tear them down. Okay, so some open source offerings. You have Graphite, which is developed by Orbitz. Orbitz is an online travel agency in the United States. I don't think they're in Taiwan yet. But in here, which doesn't show up too well, they have all the graphs on the left side, and allows you to graph anything you want in real time, even if you have thousands of servers sending it data. And I think it uses one of the messaging programs I mentioned earlier. And then you have Scalar, which does the load balancing for your cloud. So it will watch your cloud and given certain metrics, like if you have 10 machines and those 10 machines have all over 90% CPU load, it will start up another instance for you. And then there's nodules and ganglia, which actually is what you put onto your running instances, so that they will do the reporting of the health of that particular instance. So, that's it. It's a very quick overview of what software is available out there for creating your own private cloud. Does anyone have questions?
现场有人想要问问题吗？
我问个问题2个问题。第一个是你刚刚有提到 Concept 是 Open Source， 你可以告诉大家说我可以去哪里得到？可以去哪里 download 一个 copy 回来 try 吗
？OK， 所以POMSET 是用 Python 写的，所以你如果去 Python 的 PyPI， 你就用 Google 去找，那你去那边你就可以拿到那个 source， 或者你从 command line 你应该用 easy install POMSET 就可以了。
OK， 那好，那第二个问题刚刚有一个 slide 提到那个 Elester， 可以回去那边给我拍一下照吗？对，现在 TCOS 有很多人现在这个周末都忙着做 Elester， 他们很可怜，对吧？让他们来纪念一下这样。
好，
对，好，然后谢谢。好，然后第三个我在这边就是，如果说你们有对 Safe 有兴趣的话，可以过来找我这样子，因为 TCOS Elester 这个 project， 那我们最近对 Safe 这个 project 其实做了蛮多的东西。对，那也遇到蛮多很痛的地方，这样。那如果说有兴趣的话，可以找我讨论这样子。我来这边这样子，会后的话，对 ，OK。
对 ，Safe 其实很厉害，他其实刚开始是一个 University of Oregon 的博士。那因为他自己的公司是 DreamWorks， 所以他就用他公司去，就是说付他博士的学费。那现在用那个 source 那现在公司在 develop。还有问题吗？
还有其他任何疑问吗？关于说 cloud computing， 这基本上是很难得的机会，有讲者愿意跟我们分享说这实际应用会用到哪些软体啊？只是说看各位在实际应用上有没有什么样的问题需要提出来。那我这边想问一下 Michael， 就是关于刚刚您提到的那一些部分，目前比较常就是以这种形式、这种架构底下提供服务的，大概是什么样的厂商吗？就是说，可能是像阿玛荣这样的电子商，或者说，就说以您的客户来讲，就说大概是哪一类型的厂商比较多？
我觉得现在就是说很多，像我那个6月去那个 Cloud Conference 的时候，就是说大家都是现在都在重视 data management， 因为现在真的是 data 太多了。所以大家都要知道说他们怎么说去，就是把 data 去存在一个地方，那可以很快的拿回来。他们是还没有想到说，但是问题就是说，你现在 data 存了，他们还没想到说你怎么到时候去计算。对。但是现在就是最红的，我想是 data。那之后可能就是别的了。
所以应该基本上是比较偏 data warehousing 那样的厂商吗？
也是可以，但是就是说 data warehousing 跟 cloud 的 data 不太一样，对不对？因为 data warehousing，你为什么会用 data warehousing？ 因为你那个 data 不常去把那个拿出来，对不对？那你在 cloud 的话，像说你用 Facebook， 对不对？你今天你放一个照片上去，对不对？它不可能马上进 data warehouse， 因为你放上去，可能你一大堆朋友就马上要来拿，对。
谢谢。那还有其他问题吗？就关于 cloud computing 的部分。
你好，那我想请问一下，贵公司提供的核心的价值是什么呢？
哪一个公司
？Your company.
Oh, my own. Okay.
Yeah.
I see. Okay. 对，所以我们是就是做那个 cloud computing services， 所以我们会找课程，就是说他们就是大公司，他们在里面就是说他们要做自己的 private cloud， 因为他们又不能用 Amazon， 就是像我刚才讲的，对不对？他们用不了 Amazon， 为什么？他们有 security reasons， 他们有那个 performance reasons。OK， 我们现在的课程是那个哈佛医院。对不对？那哈佛医院里面他们的那个 patient 那个病人的资料不能到外面去，对不对？所以但是他们也需要有那个 high performance computing， 对不对？所以他们要自己做自己的 cloud， 所以别人来找我们。
还有其他问题吗？
不好意思，我想请问一下哦，如果要建立这样一个自己在家里这样试做一个这样的平台的话，在硬体上面有没有一个最低的要求
？OK， 所以你硬体 OK， 所以我自己我现在没带来，但是我自己常常去做 demo 的时候，我会再带我自己的用一个小书包自己带 cloud。OK， 那我这是怎么用的？我买2台 laptop， 2台 laptop 很便宜，对不对？美金得一台差不多500块，所以2台等于美金差不多1000块，对不对？那所以等于是台币3万块。对不对？台币3万块，我就前面就是一台当做，那你可以问CC，他有看过，对不对？他那个一台当做 cloud controller，OK， 那另外一台当做你的那个 cloud instance， 对，那所以我就可以用那个像我这个 laptop 直接接到 cloud controller， 就启动我的那个 cloud， 那我那个 cloud 马上就起来，当然只有2个 instance 而已，但是也是算 cloud， 对，那我这样就可以做 demo， 那。这2台机器最基本的那个硬体就是那个 processor 需要有那个 virtualization， 对，这个 AMD 好像叫不知道那个一个叫 VTX， 另外一个对不起不好意思，我那个硬体我不太懂，但是反正要有那个 virtualization 的那个 instruction set。那除了这样之外，你就其他都不需要。那所以2台那个 laptop 就可以了。Cloud controller 不需要，只有那个要跑那个 instance 的需要。
你好，那你刚刚有提到一些资料的问题，所以我在想请问你，就是说，就我对欧洲了解说，欧洲来说，如果你做 cloud 的话，它有规定使用的资料不能够离开该一个国家，也就是说你在英国的服务的英国客户，你资料存在英国，在法国的要存在法国，所以。在这方面，请问你对亚洲区这边法律的了解，它有没有一些像这种法规的限制，或者是说在会计上要做 auditing 的时候的限制？因为可能说到时候你的资料跑在不同的机械上，如果说被政府来搜寻的时候，你怎么样保证说只有单一个客户受到了 auditing 的影响，他的 server 被 shut down？
对，所以你现在讲的是 security， 那 security 其实。怎么讲？就是说，像说我们来用那个哈佛医院来讲，对不对？他们已经有 security 的系统，对不对？所以，照他们来讲，他们不能在他们那个 security 系统外面去做计算。但是我们把 cloud 搬到里面那个系统里面的话，他们就可以用，对不对？所以其实我们做的 cloud 经常没有在管说 security， 这因为是就是说你的 concern 不一样。OK， 所以就是为什么有时候你 private 你要 security， 你就是把整个 cloud 都搬进你的 enterprise。那每个公司不同的需要，就是要看他们公司有什么规定，像那个国家、那个公司、那个 industry 有什么规定。
好，那时间也差不多，那我们就掌声鼓励，谢谢 Michael 跟我们分享，
谢谢。
谢谢大家。